Yes, today we will discuss longest common subsequence problem. The main objective here behind this problem is to find the common subsequence from these two strings, right? X and Y. So let us first of all try to understand what is subsequence, right? Subsequence is a substring only, I can say, but there is a small difference, right? Subsequence is a substring from the string, but then the characters need not to be continuously available, rather, right? But provided they are in the direction from left to right. For example, if you look at this particular string A B C B D A B, in which I can just pick up few characters, from left to right. Like for example, AC, I can say AC is a subsequence, right? But this AC cannot be a substring. So with this discussion, what I can conclude that a substring can be a subsequence, but subsequence cannot be a substring. Now we are here trying to find out the subsequence, the longest common subsequence from these two strings, right? So in order to find the longest common subsequence, what we need to first do is we need to find out possible subsequence that are available across both the strings, right? So what are all possible subsequences that are available across this X and Y? So if you probably take X, right? A is a subsequence, A B, A C, right? Fine. So here, all such subsequences that you can when list out. Similarly for Y, then from those two, we need to find out the uh, longest one. Fine. This is what our motive behind uh, discussing this particular problem. So if you look at brute force solution to find this, with the help of a recurrence relation, we can solve this. So basically, this LCS problem here being solved using the dynamic programming. As we know that there are five majorly available designing techniques for algorithms, right? Uh, Divide and conquer, like many of the sorting algorithms like mud sort, binary search, all are based on this divide and conquer. Then you have greedy. Madam, I think I got this. Then greedy is another technique. Like for example, knapsack problem. And then we have dynamic programming, right? So the difference between greedy and knapsack is in greedy you will have only one set of sequences, and the set of sequences that you take are placed in the optimal order before itself. Okay, placed in the optimal order before itself. And while finding the solution under greedy, what you do is from this particular set of sequence, you will pick the inputs. You will pick the inputs one after the other. Okay, you don't take all the inputs at a stretch. Rather, one after the other, you take the inputs and see that you are able to solve it. Right. Once you reach a position stage where you are able to solve it, you stop picking the inputs from the same rather, right? So this is your greedy. So in greedy, what happens, the set of sequences are static, but here in dynamic programming, what happens, you start with any state. Okay, the first state could be anything, but then the subsequent state, right? uh, you to choose with, you have multiple, you know options, right? Multiple options. So from the first state, when you are moving on to the second state, you can take any one of these options. Then in order to move to the next subsequent state, again you will have a couple of options, out of which again you can choose any one, right? So it means that here you are able to decide the states, right, dynamically during the runtime. Fine. See, you start with any state initially, and then while executing your task, you will choose the next state from the possible states that are available, right? And how these states are going to be made available for you, with the help of certain heuristic equation, right? And then from them you will choose one optimal which can lead to your answer node or goal node, to in order to reach the next state, subsequently next state, until you reach the goal node, right? So this is the technique behind dynamic programming. Fine. So in greedy you will have only one set of sequence, but whereas in dynamic programming you can see you have multiple sets of sequence in order to reach the goal node, right? And you can change the states during the runtime based on your choice. So here, this is all being done with the help of some heuristic functions, right? Heuristic functions. So most of the dynamic programming algorithms are solved based on the heuristic equations, right? So these heuristic equations are basically designed using the recurrence relations, right? Using recurrence relations, right? Based on certain past statistics. Okay. So similarly here, if you can see in this longest common subsequence problem, this is the heuristic equation that is generated in order to find the optimal solution for the longest common subsequence. So to find the length of the longest common subsequence from the given two strings, where this I and j acting as the indices over those two strings when they are represented in the form of arrays, right? So using this formula, len LCS of I comma j equal to 0 if I equal to 0, j equal to 0, or otherwise len LCS of I minus 1 comma j minus 1 plus 1 if ij is greater than 0 and xi equal to yj. Fine. The maximum of the len LCS I minus 1 comma j len LCS of I comma j minus 1 otherwise. Okay. So when I equal to 0, j equal to 0, it is 0. If ij greater than 0 and xi equal to yj, then you go with this. Otherwise, you go with this, right? This heuristic function, right, is determined based on the past statistic for this particular longest common subsequence problem. So our objective is to find the longest common subsequence among the two strings, that is x and y, right? So using the same formula, of course, you design the algorithm as well. Writing algorithm is quite easy for dynamic programming. Only thing is you have to apply this formula under the nested loops rather, right? Initialize the first row and the first column of the matrix, len LCS to 0 first, calculate the len LCS 1 comma j for j equal to 1 to n, then len LCS of 2 comma j for, like that you find out, store also in a table and an arrow pointing to the array element that was used in the remedy. The complexity, if you look at it, is big of mn, but then when you program it, it is kept inside the nested for loops. Since you have two iterators I comma j, so you use two for loops and then implement the same. You can see the algorithm here. Initialize first that matrix to 0, and then you can see here with the three conditions that we have designed that particular heuristic formula. When xi equal to yj, we said Cij equal to Ci minus 1 comma j minus 1 plus 1, right? Otherwise, we said Ci minus 1 comma j is greater than or equal to C of I comma j minus 1. C of I comma j gets C of I minus 1 j. B of I comma j gets, u. Fine. So, otherwise, you will be moving it to the left. So, this is the algorithm which is basically here used in order to implement this LCS using that particular heuristic, you know, function, right? And the complexity is mn, right? Now, let us try to identify the longest common subsequence from these two strings, right? These two strings, A, B, C, B, A, B, C, B, D, A, B, B, D, C, A, B, A. So if you probably look at B, C, A, B, B, C, A, B, C, A, right? This is one common subsequence. You can see B, C, B, A, B, C, B, A, B, C, B, A, and B, D, A, B, right? B, D, A, B, B, D, A, B, right? So, how many? These are the possible some common subsequences that could identify. But then, the longest common subsequence is having how many characters? Four characters for this particular. Either it could be BCBA or you take BDEB rather, right? So this is what exactly we are trying to find with the help of this particular algorithm. So this LCS problem, if you see, it is implemented using dynamic programming. Fine. So in dynamic programming algorithms, you will have a heuristic function of this kind, which is basically derived based on some past statistics. Fine, and implementing the algorithm is quite easy. Just putting them in a nested for, you can probably implement it. Fine. The tracing of the same is mentioned here. You can see this. You know, for example, BDCA and ABCB, right? I hope this is clear to all of you.